Cloud computing and digital storage have transformed how society operates. From personal photo backups to global business infrastructure, digital storage allows people and organizations to save, manage, and access information instantly. Behind every uploaded photo, streamed video, downloaded file, and saved document is a massive physical infrastructure. Servers, storage devices, networking systems, cooling equipment, and power supplies work continuously to support digital access. This infrastructure grows every year. As digital demand increases, so does the need for hardware. While cloud computing offers convenience and efficiency, it also creates an environmental challenge that is often overlooked. The hardware behind digital storage eventually becomes obsolete, creating a growing stream of electronic waste. This presentation explores how cloud computing contributes to e-waste, the environmental consequences of digital infrastructure, and the solutions that can support a more sustainable future. When people think about the cloud, they often imagine a digital space disconnected from physical objects. The reality is very different. Cloud computing depends on an enormous network of physical hardware. Every file stored online exists within a data center somewhere in the world. These facilities house thousands of servers operating around the clock. Each server contains processors, memory systems, storage drives, networking components, and cooling systems. The cloud functions because this hardware processes, transfers, and stores information continuously. Digital services such as streaming, social media, remote work, artificial intelligence, online banking, and smart devices all rely on this infrastructure. Every online interaction increases demand for computing power. As usage expands, additional equipment must be installed. This means the growth of digital technology directly increases hardware demand. The cloud may appear invisible to users, but it depends entirely on physical systems. Understanding this hidden infrastructure is essential when discussing e-waste and sustainability. Without acknowledging the physical side of digital services, it becomes difficult to fully understand their environmental impact. Cloud infrastructure is made up of several interconnected systems. At the center of this network are data centers. These large facilities contain racks of servers responsible for processing and storing information. Servers are the backbone of digital storage. They manage applications, websites, backups, databases, and cloud-based platforms. Storage hardware is another essential component. Hard drives, solid-state drives, memory arrays, and storage clusters hold massive amounts of information. Networking equipment allows data to travel between users and cloud systems. Routers, switches, fiber connections, and communication hardware keep digital services connected. Power systems and cooling infrastructure also play a major role. Servers generate heat during operation. Cooling equipment prevents overheating and maintains performance. Backup generators, battery systems, and power management devices ensure uninterrupted operation. Together, these systems create a vast ecosystem of physical hardware. Each component contributes to the overall environmental footprint of cloud computing. The more digital services expand, the larger this infrastructure becomes. Cloud computing is often viewed as environmentally friendly because it reduces physical media and local storage. However, the cloud creates its own form of waste. As demand for digital services increases, providers must continuously expand infrastructure. New servers, storage devices, networking equipment, and cooling systems are installed regularly. Older hardware is removed to make room for newer technology. Even functional equipment may be retired if it no longer meets performance expectations. Large-scale upgrades create large volumes of retired electronics. Unlike household electronics, these systems are often replaced in bulk. Entire server racks may be removed during modernization projects. This creates significant e-waste. Because the hardware is hidden inside data centers, many consumers are unaware of the waste generated. Streaming media, online backups, artificial intelligence, and cloud applications all contribute indirectly to this growing infrastructure. The digital world appears clean and virtual, but the physical systems supporting it have a measurable environmental impact. Recognizing this hidden waste stream is essential for sustainability planning. One major reason cloud computing contributes to e-waste is the relatively short lifespan of hardware. Data center equipment operates continuously. Servers often run 24 hours a day, 7 days a week. This constant activity accelerates wear and reduces equipment lifespan. Many organizations replace servers every few years. Even if systems remain functional, newer equipment may provide better energy efficiency, faster processing, or greater storage capacity. Storage devices also experience gradual decline. Hard drives and solid-state drives degrade through repeated read and write cycles. Eventually, performance drops or reliability becomes a concern. Rapid technological innovation encourages frequent upgrades. Organizations compete to deliver faster cloud services and improve digital experiences. This creates pressure to adopt the latest hardware. As replacement cycles shorten, e-waste volumes increase. Retired equipment must be stored, repurposed, recycled, or disposed of. Without effective lifecycle planning, hardware turnover creates long-term environmental challenges. The growth of digital data is happening at an extraordinary pace. Every day, billions of users upload photos, stream videos, send emails, access cloud applications, and interact with connected devices. Businesses generate enormous volumes of information through analytics, security systems, customer records, and operations. Artificial intelligence and machine learning also require massive data storage. Smart devices add another layer of demand. Connected homes, wearable technology, industrial sensors, and smart cities continuously create information. As data volume increases, infrastructure must grow to support it. More data requires more servers, more storage systems, and larger facilities. Expansion creates a cycle of increased hardware demand. The larger the digital ecosystem becomes, the more equipment is eventually retired. This means future e-waste volumes may continue rising alongside digital growth. The scale of cloud infrastructure creates a long-term sustainability challenge. Organizations must think beyond storage capacity and include hardware lifecycle planning. Without responsible management, the growth of data can lead to equally large growth in discarded electronics. Electronic waste creates serious environmental concerns. Servers, drives, and networking equipment often contain hazardous materials. These may include lead, mercury, cadmium, flame retardants, and chemical coatings. If electronics are improperly discarded, harmful substances may enter the environment. Landfill disposal creates long-term risks. As electronics break down, chemicals can leach into soil and groundwater. This contamination may spread through ecosystems. Air pollution can also occur when electronics are burned or dismantled improperly. Informal recycling operations may release toxic fumes and residues. Cloud-related hardware contributes to these risks because of the large volume of equipment involved. The environmental impact is not limited to waste alone. Manufacturing replacement hardware also consumes energy, water, and raw materials. Frequent replacement cycles increase demand for mining and production. Reducing e-waste helps lower environmental pressure throughout the technology supply chain. Responsible disposal protects ecosystems while preserving valuable resources. Improper e-waste management creates health risks for workers and nearby communities. Electronic equipment contains substances that can become dangerous when handled incorrectly. Exposure to toxic metals or chemical residues may affect respiratory systems, skin, and long-term health. Informal recycling sectors are especially vulnerable. Workers may dismantle electronics without proper protective equipment. Unsafe handling increases exposure to dust, fumes, and hazardous materials. Cloud-related infrastructure contributes to this issue when retired equipment enters poorly regulated disposal streams. The global movement of e-waste means discarded hardware may travel across borders. In some regions, waste is processed in unsafe conditions. Communities near informal recycling sites may experience contamination. Safe recycling practices protect both people and the environment. Controlled processing, protective equipment, and environmental safeguards reduce risks. Responsible disposal helps ensure that technology does not create hidden health consequences. Human safety should remain a priority throughout the hardware lifecycle. Not all retired hardware immediately becomes waste. Many servers and storage systems still function after leaving high-performance environments. Organizations can extend hardware life through reuse. Equipment that no longer meets enterprise-level requirements may still support secondary applications. Refurbishment is one important strategy. Testing, repairing, and upgrading systems allows them to remain useful. Repurposed equipment may serve educational facilities, smaller businesses, or backup systems. Reuse reduces pressure to manufacture replacement equipment. Extending device lifespan improves sustainability. The longer hardware remains useful, the fewer devices require immediate replacement. This reduces e-waste volumes. Reuse also creates economic value. Organizations may recover value from retired equipment instead of discarding it. Lifecycle extension supports responsible resource management. Rather than treating all retired equipment as waste, reuse creates additional opportunities for efficiency. Reducing cloud-related e-waste requires better lifecycle planning. Hardware design plays an important role. Manufacturers can build systems that are easier to repair, upgrade, and recycle. Modular components allow individual parts to be replaced instead of entire systems. Responsible decommissioning is also essential. When equipment is retired, it should be securely wiped of sensitive data. Devices should then be evaluated for reuse or recycling. Advanced recycling technologies can recover valuable materials. Servers and storage systems often contain gold, copper, aluminum, and rare earth elements. Material recovery reduces the need for mining new resources. Licensed recyclers support secure and environmentally responsible processing. Authorized recycling facilities help manage hardware through proper dismantling and recovery. Responsible recycling prevents harmful disposal while preserving valuable materials. Lifecycle management must become part of cloud infrastructure planning. Organizations that plan for end-of-life recovery reduce both environmental and operational risk. Cloud computing is essential to modern life. Digital storage supports communication, business operations, entertainment, healthcare, education, and countless other systems. However, sustainability must become part of the conversation. The hidden hardware behind the cloud creates real environmental impacts. Reducing these impacts requires a long-term approach. Optimization can help reduce hardware demand. Virtualization, efficient coding, and improved software design allow systems to operate with fewer physical resources. Lifecycle planning ensures hardware is reused, repurposed, or responsibly recycled. Collaboration across industries is also important. Manufacturers, cloud providers, businesses, governments, and licensed recyclers all contribute to sustainability. A shared commitment to responsible technology management can reduce waste. The digital future should not only focus on convenience, it should also prioritize environmental responsibility. By understanding the hidden infrastructure behind digital storage, organizations can make smarter decisions about how technology is managed throughout its life cycle. Thank you for exploring the e-waste impact of digital storage and cloud computing. Understanding the physical infrastructure behind digital services helps create awareness about hidden environmental challenges. As cloud technology continues to grow, responsible lifecycle management becomes increasingly important. Proper reuse, recycling, and recovery strategies can help reduce the environmental footprint of digital systems. If you are looking for support with electronics recycling, equipment decommissioning, or responsible disposal solutions, assistance is available. Together, we can build a cleaner digital future by understanding the hidden hardware behind the cloud and recycling it responsibly.